So we have a pendulum bob with a mass of capital M is released from the horizontal position shown in the diagram. That's this one here, that's first point, and swings down to the vertical position where theta minus 90 degrees. I think that's meant to be theta equals 90 degrees, and that's this position here anyway. Okay, before we get started, a couple of important things to note, things to be aware of that might produce a bit of confusion or silly mistakes later. We're dealing with a capital M. Usually there's a small m, so if you're talking about the weight force of the pendulum bob, it would be capital Mg rather than small mg. That could produce confusion later, so I'm just making a mental note of it. And we're also measuring the angle from the horizontal position, which is quite important. Usually you measure it from the vertical, so that the first one over here would actually be 90 degrees if you're dealing with it from the vertical. Okay. Also, this is clearly not going to be simple harmonic motion. Because simple harmonic motion deals with a small angle approximation, and I think, yeah, that's what the first question is actually asking about. So let's get into it. A. Explain why the motion of this pendulum will not be a simple harmonic motion. Okay, well, there's a couple of ways you could approach this. I've already said one main point, which is that SHM uses small angle, small theta, which is less than about 10 degrees. That's from the vertical as well. So in this case it would be greater than 80 degrees, or theta is greater than 80 degrees for this diagram above, with theta measured from the horizontal. The other thing is what that implies, because remember the definition for simple harmonic motion is always a good place to start. Simple harmonic motion is where the restoring force is directly proportional to the displacement, and that's the horizontal displacement from the equilibrium in either direction y. Okay, so in this case it's definitely not the case, because the horizontal displacement here is not proportional to the restoring force. In fact, there's no restoring force initially, it's just the force due to gravity over here. So, not true. I think you could go into a bit more depth explaining each of these things, but that's the essence of it. Looking ahead, there's probably going to be questions analysing the forces at different points, because with this restoring force being proportional to the displacement, not holding true in this case, they're probably going to want to analyse what those forces actually are